So if we look at it, we're first trying to find our vertex. So our vertex is where our parabola changes from either increasing to decreasing or decreasing to increasing. So it's the change in slope, right? So the vertex here is this point here. So that's at 2 on our x and 12. So 2, 12, right? This is our vertex. Our axis of symmetry is the x value of vertex. Right, so the x value of vertex is x equals 2. So we make a line through x equals 2 all the way down. Right, and that's our axis of symmetry. Okay, so axis of symmetry means if you look, say these 2 points here, right, they're the same distance from that line. Okay, because it's a reflection over that line essentially. Okay, so that's what the axis of symmetry tells us. Y-intercept is where crosses the y-axis. Right, so it crosses the y-axis right here, which is at 0, 0. So y equals 0 would be our y-intercept. Our x-intercepts, why does it keep going? Is where it crosses the x-axis. Right, and it crosses the x-axis at x equals 0 and x equals 4. So x equals 0, comma 4. Last is domain and range. So domain is all x values or inputs, and then the range is all y values or outputs. So if we look, this is going to continue down all the way to the left to negative infinity and all the way to the right to infinity. All right, so it's going to keep going from negative infinity to infinity. So our domain is negative infinity to infinity. Our range is all y values. So our highest y value is y equals 12, right? And then it's going all the way, continuing down to negative infinity. So it starts at negative infinity, right, and ends at 12. It does include it, so there's a bracket there. Okay, so this is number 1. You might have a different graph because these are math XLs. Everyone gets different questions, but essentially this is the same exact way to solve it. So when the function is positive, it's when it's above the x-axis, and when it's negative, it's below the x-axis. So when it's above the x-axis, starts here and then goes on, and starts here and goes on. Right, so this is positive and this is positive. When it's negative, it's below. So it's down here to here. Okay. So it does not include those points at when y equals 0 because when y equals 0, it's neither positive or negative. Okay, so your intervals are going to be using parentheses. So this one starts at negative infinity and then stops at 1. So negative infinity to 1. And then again, it's positive starting at 5, but not including it, and then going to infinity. So this is when it's positive. Then our function is negative, right, where we marked red starting at, sorry, it's negative 1, so this should be negative 1 here. All right, so negative 1, and then stops being negative at 5, but not including it. Okay. So, right, what we can mark first, I would mark the transformations, right? We have our h is equal to 6 and our k equals 5, right? Remember, h, it's x minus h in our formula, so technically our h is positive 6 there, right? H tells us when it goes, h equals positive 6, it goes to the right 6, and then k equaling positive 5 means up 5. Okay, so those are the transformations, right 6, up 5. Now our vertex is h comma k, because we're moving our vertex to the right 6 and we're moving it up 5. So our vertex is h comma k, therefore our vertex is equal to 6 comma 5. Then our axis of symmetry, we said, is the x value of the vertex. So our axis of symmetry is x equals 6. So in this problem, we're reflecting over the y-axis. So reflection over the y-axis is g of x, meaning our transformation is equal to f of negative x, meaning make all x's in the function negative. Okay, so, right, g of x is equal to negative 9 times negative x, okay, which becomes positive 9x, and that's your answer. Pretty easy on the y-axis. If it was reflection over the x-axis, what you would do is you would make the whole function. You'd multiply negative 9x times the negative 1, right? You'd make the whole function negative for x-axis. This is similar to the other question about transformations. So it says sketch the graph. Obviously, there's no graph to sketch on here, but essentially what we're doing is we're just moving our vertex of the x squared function, which is a parabola. And it says the graph of f of x is exactly the same graph of x squared, except, right, we're shifting 6 units somewhere and 2 units somewhere, right? So our h, so let's identify our h. Our h is equal to positive 6. We know when it's positive, it goes to the right, so it's going to the right 6. Then our k is negative 2. Therefore, it goes to down 2. So when you fill these in, right, you'd say 6 units to the right and 2 units down. All right, so this problem says graph the function and identify intervals on which the function is increasing or decreasing or constant. So what I advise you to do, so essentially our parent function is f of x equals absolute value of x, but this moves to the left 3 because h equals negative 3. And then it also moves down 5. So that's because k equals negative 5, right? Now, what you can do is use Desmos.com. If you go to Desmos.com, and you can graph it on there, or you can hand graph it, okay? This shows us the graph of this function. So you just type the function in and it'll graph it, right? We can see our vertex is moved to the left 3, and it's negative 3. and then down 5. So our vertex is -3, -5. Right? We want to find where it's increasing or decreasing or constant. So increasing, actually, I'll change the color. Right? So we know increasing means it's a positive slope. Positive slope, meaning it goes like up and to the right or down and to the left. So we can see starting at -3 and going on to infinity, we have a positive slope, so is increasing. Then decreasing is when we have a negative slope, right? Meaning it goes down and to the right or up and to the left, right? And we see that starts at negative infinity and then stops at -3. Okay, so our decreasing is negative infinity and then stops at -3. It does not include -3 because at that point it's neither increasing or decreasing. For the positive, right, then it started at -3 and then went to infinity. And then the last one, constant, right? Constant just means a slope that looks like this, which is a slope equal to 0. Okay, so when you have a horizontal line and your slope is equal to 0, so it would be like f of x equals some number or y equals some number. All right, now this one says graph the piecewise function given the domain and range. So let's first find the domain and range of each one. So this domain, right, starts at negative infinity, right? Keeps on going all the way to negative infinity and then ends and includes 0. Right, so we could also say x is less than or equal to 0. This other one starts at 0, but does not include it, and then goes to infinity as it, right? It keeps going all the way to the right to infinity, or we can say x is greater than 0. Okay, so first we can pick out whether it's a or b, given x should be less than or equal to, right? Which is b. Okay, so less than or equal to 0. That's a bad color to write with. And then greater than or equal to 0, right? So first we found our domains. Now we just need to find the lines. Well, this line is just a horizontal line. So that line is just at y equals 4. So for this one, for x is greater than or equal to 0, it should just be a 4. Actually, I don't even need to make the arrow for that. Okay. The next one you got to find out. You could solve for your y-intercept, but we actually see it's at 0. So our y-intercept equals 0, so b equals 0 for this line. And then you just got to find your slope. Well, it's going up 1 to the right 1, so our m is equal to 1. So it'd be y equals 1x plus 0, or just x. So our function would just be x. All right. For this piecewise function, we can't really tell the domain of each. We know they change at x equals -2, but you can't tell which includes it and which doesn't. So in order to solve this, we need to find the slope and y-intercept of both. Okay. For this graph on the right side, um, we can easily find the slope of this. So, right, it goes up 1 to the right 1. So our slope of this line here is m equals 1. And our y-intercept is at 0, so b equals 0. So this graph is when x is either greater than or x is greater than or equal to -2, our f of x is x, right? Because it's your slope is 1 and your y-intercept is 0. Okay, so, and you can kind of see, right, x is in all of them, so we need to find the other one to kind of cancel things out. Okay, but we know for x it needs to be either greater than or equal to, or greater than -2. So if we look at all the greater thans, so it's going to be greater than or equal to. So this one is not going to be true, and neither is this one, right? It's not going to be x is less than for x. So we're either looking at A or B. Now we need to find the slope of this one. So the slope is up one to the left one. So our slope is -1, right? And then if we continue this line, our y-intercept is going to be at -4 for this. Right? Therefore, our for x is less than 2, -2, it's going to be, oh, sorry, f of x is equal to, slope is -1, so -x, and then we have a b of -4, so -x minus 4, so therefore our function is b. All right, so for this problem, we need to solve graphically. So when you solve graphically, you need to graph both equations. So graph both equations, and then find the intersection. All right, so our first one is x minus 5. So it's at -5, and the slope is 1 over 1. All right, so x minus 5. We'll make the other one red. So this has a intercept of 15, and then slope of -1/4. So down 1 to the right 4. Yeah. Down 1 to the right 4. So this is our graph here. Oh, that's a bad graph. So we're gonna have to extend this graph further. Okay. So this is x minus 5, and this other one was 15 minus 1/4 x. Now, when you did it, you were able to do it using the online graphing, so it was probably easier to draw this. But then you find the intersection, which is here. So intersection was at 16, 11, yeah, or x equals 16 is the solution, right? Because for graphically, right, we just find the x value of the intersection. All right, for this problem, you're solving graphically. So what I did was I used Desmos to graph both sides. The first one is an absolute value function with a vertical stretch, so it gets thinner, and you find your vertex by plugging in 0 for y. This is because you have no vertical change for absolute value of 2x plus 2. So we're going to set that equal to 0 to solve for our x value. Get -2 equals 2x, and x equals -1. Right, as you can see, -1, 0 is your vertex. Okay, and then the other one had a y-intercept of -6. So 0, -6, right? And then a slope of 6 over 1. So up 1 to the right. Oop, 6. Sorry, to the right 1, up 6. There's 1 point, and then the next point is here. And then we can see by graphing these two, there's an intersection at 2, 6. So our solution is x equals 2. All right, here's your intersection. So you can use, again, Desmos.com to help you graph these if there's no like graphing tool in Math Excel. So for this next one, I also use it to graph both sides, 2x and x minus 5. And then I got to find my intersection, which you can see is -5, -10 there. So we're looking at the x value equal to -5. This says we're looking for when 2x is below because it's less than, or intersecting because it's equal to x minus 5. Okay, so our red line is the 2x, right? So we want to find where it's below. Okay, so right here it's below the blue line, right? The red line is below the blue line. So we can say that's going to -infinity, right? And then it stops and is equal to -5. X equals -5 is the intersection. Therefore, right, this is going from x is less than or equal to -5. That's our solution. So you put in -5 here, and that's what you get for your solution, because you're looking for it's less than or equal to, so it means below and where it intersects, and that's this 2x is below the blue line when it's less than or equal to -5. All right, this last one says elimination, but on the quiz you're going to get most likely a substitution. So we're going to solve this by substitution. Right, and substitution tells us to get one variable in one equation by itself. So the easiest one is this y, because it has a coefficient of 1, so we can just make it y equals, we're going to add the 5x to the other side, so it makes it 5x plus 31. Now, what we're going to do is we're going to substitute this into the y for the other equation. So I'm going to rewrite the next equation as 5x plus 3y equals -27. Now we're going to substitute in 5x plus 31 for y. So 5x plus 3 times this 5x plus 31. Right, this allows us to have all x's in our equation so that we can solve. Okay, so now we have to distribute the 3. We get 5x plus 15x plus 93 is equal to -27. Okay, now we can put this x's together, and we can also subtract 93 from both sides. So we get 20x minus 93 is equal to -120. And then we have to divide both sides by 20 to get our x. So x equals -6. Now, right, we bring this over here. Y is equal to 5x plus 31. And we're going to substitute in -6 for x. And this will allow us to solve for y. So we get y equals 5 times negative 6 plus 31. So we get negative 30 plus 31, which equals 1. So y equals 1. And our final solution, remember, for 1.6 was in coordinates or ordered pair, so x, y, so negative 6, 1 is our solution. Okay, so that is the preview for the quiz. So you'll have this video to look at, and then on Thursday next week we'll meet to go over some of the quiz, and then you'll have till that following Monday to turn it in. But this will be a quarter 2 grade.